In the 2015 Women's European Gymnastics Championships, two of the events were the vault and the balance beam. Jeff thinks the scores may be modelled by normal distributions. For the vault, the competitor's mean score was 14.5 and the standard deviation was 0.6. One competitor scored 14.1 in the vault. Calculate the standardised score for this competitor. Give your answer correct to one decimal place. So to calculate the standardised score, we take the score, so 14.1, we subtract the mean score, 14.5, and we divide by the standard deviation, which is 0.6. So if we do that, that's going to give us minus 0.666 and so on, which to one decimal place is minus 0.7. The same competitor had a standardised score of 0.5 for the balance beam. Compare the performance of this competitor in the vault with her performance in the balance beam. So we can see here that 0.5 is bigger than minus 0.7. So the standardised score is higher for the balance beam than the vault. Therefore, the competitor did better on the balance beam than the vault. The high score in the vault was 15.3. Use standardised scores to discuss whether or not the scores in the vault may be modelled by a normal distribution. The first thing we're going to do then is we're going to calculate the standardised score for the high score, which is 15.3. So we do 15.3 minus the mean score, which is 14.5, divided by the standard deviation, which is 0.6. And that gives us a standardised score of 1.33 recurring. Now, this means that the highest score is only 1.33 standard deviations above the mean. Now we know that 95% of the data is within 2 standard deviations of the mean, if it's a normal distribution. Okay, and in this case, we know that no data is more than 1.33 standard deviations above the mean. But in a normal distribution, because 95% of the data is within 2 standard deviations, a very small piece of the data should be outside of 2 standard deviations away from the mean. And in this case, that's not the case. So therefore, this is not a normal distribution, or a normal distribution is not suitable for this.